Hello friends, this is Durga. Good morning to you all. So we'll start the hangout in very soon. Before that, let me copy paste the link in the YouTube video also, so that people who actually log in through YouTube can come to events page if they want to ask the questions. And then we'll start today's topic. Okay. Just a moment, we will start. I'm just sharing the details of this event as part of the comments. If someone want to ask questions towards the end of the session, we will see. So I have pasted the link, the event link in the YouTube video, and now I'm sharing my screen so that we can actually start. So already a couple of guys are have started asking questions. Hold on until last few minutes. So we'll go through the agenda, and then I will start answering to your questions. So as you can see, the agenda is first I will talk about itversity, about Hadoop ecosystem, then Spark, then why Spark is getting a lot more popular, what is the future of Hive, Pig, Sqoop, Oozie, etc. Will there be any impact because of the Spark? And also, what are the resources at itversity with respect to Spark? Those are the things which will be covered. So first about itversity. itversity is a Dallas-based startup. We are primarily focusing on providing content at no cost or very low cost to the people who want to build their careers in IT. As of now, it's about big data, mostly about big data, but in future, we will try to get into the other emerging technologies as well, not just big data. So we run to teach at no cost or very low cost. We run a channel called itversity. So you can go to YouTube and search for itversity. So this is my channel. You can subscribe if you want. And there are many playlists covering many topics. Sometimes the topics are redundant, but the reason is we create a video and we make it part of multiple playlists. The idea is behind playlist is to have all the related videos of a particular topic in a proper flow, so that people learn over time by following those videos. Okay, for example, if I show you, let me show you this big data certifications. There is a course on. There are several courses. One of them is this one, Hortonworks Data Platform Certified Administrator. This is about getting certified as a Hadoop administrator. And you can see there are 67 videos, and it starts with the introduction. The flow will be same if you go through this playlist. And if you click on play all, you will start seeing the videos in a series. Or even if you click on the first video in the playlist, you will actually see the playlist here. You can see one of 67 videos. Make sure you do not click on shuffle. If you click on shuffle, then the videos can play in no particular order. Okay, so this is how we started uploading the content. There are many other playlists. You can go to the channel page again and check for the playlists here. Okay, there are many more, and you can even scroll down a little bit and you can see that I have created sections so that related playlists are grouped together. Okay, so like that, there are a lot of there are around 825 videos, and there are hundreds of playlists out of those 825 videos covering a particular topic. And then we recently launched a website called www.itversity.com. And here, as of now, there are only one course, one full course, and two startup course, getting started courses are 101 courses. The course is CCS Spark and Hadoop Developer. You can click on this, And you can see this is a full course, and there are lessons in this course. On the right side, you have introduction, you have data ingest using Sqoop, data ingest using Flume and HDFS, transform state store using Spark with Python, blah, blah, blah. So all the topics that are related for this CCS Spark and Hadoop Developer Certification course published by the certification. Let me share my screen. The screen share is stopped. Okay. So now you should be able to see my screen. So this content is primarily built upon the official certification exam curriculum. So this is the official page of the certification, and based upon the curriculum, the content is developed. So you can follow courses like this, and you can get certified. As of now, there is only one course, but eventually there will be many courses. We are planning to upload at least one course every 45 days. So in a year, there will be approximately 8 to 9 courses for different topics. Okay. So that being said, now we'll get into the actual topics about Hadoop ecosystem, about Spark, why Spark is getting more popular, etc. So for that, I have a big data introduction presentation. I'm using that. I have covered already this one as part of the earlier Hangouts. So if you want to follow me, stay connected with me Google Plus, and I will try to conduct a series of Hangouts. If you follow a particular series, you will gain some insights. It will not be the complete topic that will be covered as part of the Hangout. The complete topics will be covered as part of the videos, but definitely will get some idea by following the Hangout series also. I will try to conduct. I will come up with a plan, and I will try to conduct a series of multiple Hangouts. So for this explanation of difference between Hadoop and Hadoop MapReduce and Spark, I will take the example of enterprise data warehouse or data integration in big data ecosystem. Okay, so this is the traditional way of 1 minute. Yeah, this is the traditional way of building the data integration platforms or building the enterprise data warehouse. This is even before big data comes into picture. You will have multiple sources. The sources can be OLTP systems or mission critical systems or transaction based systems. They can be closed mainframes applications. They can be external apps. And then in the middle, you will have a centralized data warehouse, and you will have something called ODS as well as data warehouse. If you want to understand what is ODS and what is data warehouse, you need to refresh your data warehousing concepts. But just remember that there will be a couple of databases from using which we will build the data warehouse and perform the transformations that are required for the visualization later. Okay, and then to get data into ODS and data warehouse, you need to have a data integration platform. ODS is a database. Source can be a database like OLTP. It could be mainframes application. It could be external XML applications, XML-based data sets which you might be getting. So you have multiple types of data formats that will be coming into your target system, which is enterprise data warehouse or big data, whatever it is. In this case, I'm taking enterprise data warehouse as example. So as part of the data integration, you have to get data from these multiple sources, you perform certain transformations, and store into these target databases. So when you actually implement using conventional way, the data warehouse is typically built on Teradata. The applications and the technologies such as Teradata, Greenplum, Vertica, etc. They are fine-tuned to implement data warehouses. And then ODS is traditional RDBMS like Oracle, MySQL, etc. And then data integration layer uses Informatica. So Informatica, Data Stage, and any other ETL tool can be an example as part of the data integration layer. So here, so data warehouse requires a different hardware architecture because you will be buying Teradata appliance. Teradata appliance is like your laptop or your computer, but it's a server, and it comes with everything. It comes with multiple physical machines, network mounted storage, and also network switch to connect to the storage and the servers. It's a full-blown appliance. It will look like a big desktop. Okay, and that's what Teradata provides. On top of the hardware, it also provides the software which can store the data effectively. And that's about Teradata, which will be used to store which is used as data warehouse. It's a technology which is used for the data warehouses. And then ODS, you don't need to buy this expensive appliance. You can use traditional databases as well for ODS. And typically they use MySQL or Postgres or Oracle, whatever database the company is comfortable with, they use that one. But ODS, the traditional databases does not come with hardware. It's just a software, so you have to buy servers which can support the databases, some high-end servers, and then you have to install the binaries of respective database which you want to use, and then you have to take care from there. So it requires a different type of hardware for data warehouse. It requires different type of hardware for ODS. And then when it comes to data integration, Informatica or Talent, take any ETL tool, it requires its own hardware. Okay, that hardware need not be as powerful as ODS. Even Informatica come as only software; it does not come with hardware. Yeah, and the hardware required to set up Informatica need not be as complex and as powerful as databases that support, the servers, the physical machines that support the databases. So here you have multiple things in that you need to understand when you try to implement a data warehouse using conventional technologies such as Teradata, Informatica, Oracle, etc. Each technology requires different type of hardware, so the heterogeneous hardware, and over time the support of these multiple hardwares can be cumbersome and expensive for the companies, and also they cannot scale with larger data sets. They work well with smaller data sets, but if you want to process data from sources such as social networking platforms, mobile phones, etc., these cannot scale. Okay, so and then you have the visualization layer. I don't want to get into all those things at this time. So the same thing, the same EDW or data integration framework or data analytics platform, if you have to build with big data ecosystem. Okay, here you just need to have multiple nodes for Hadoop. So you can use our big data. You can set up a big data cluster. When I say big data cluster, it includes Hadoop, and also it has other complementary tools which might not be directly related to Hadoop, but which can facilitate you to perform certain operations, and they can be hosted in the homogeneous hardware. You get one set of one type of servers, and then you can actually start building your ODS, enterprise data house, everything, as well as ETL, everything on top of that homogeneous hardware. Okay, now you can see that we just have one type of hardware, so operations can be simplified, will be simplified, and you are having ODS, not only data in the form of ODS and EW, but also ETL can be performed using the big data technologies. But don't think that development with this architecture is simple. Okay, from the hardware perspective, on for day-to-day operations, for day-to-day maintenance, it simplifies quite a bit over time for the companies. But when it comes to implementing the projects, it is quite cumbersome because you have to use multiple tools. I will explain what all those tools you need to use to implement this end product of analytics platform. EW is one kind of analytics. EW might not be the right example for analytics, but you can the projects or the applications which will be deployed in EW or analytics are similar. Okay, and then You have to integrate data into those. You need to have when it comes to implementing using traditional tools of Hadoop or MapReduce based tools, you need to have a reporting database. We will understand why we need to have this when we actually see the challenges which you encounter with MapReduce based tools. Okay, that I will cover later. But this is the overall architecture about how you can actually build analytics platform using big data ecosystem pre-Spark, before Spark is involved. The design will be same even with Spark, but the technology stack will be different. So now this is again pre-Spark diagram. So you have a distributed file system. If you are familiar with Hadoop already, so you should have some knowledge about Hadoop to be part of this hangout. If you are completely new, then you might have some challenges to understand. If you have some knowledge, you will pick it up very quickly. So you have HDFS at the bottom, and then you have two types of tools on top of HDFS to process the data. One is MapReduce based tools, and the other one is non-MapReduce based tools. So when it comes to MapReduce tools, MapReduce based tools, you have Hive. Hive is similar to SQL. So if you want to create a database or data warehouse in Hadoop on top of HDFS, Hive is one of the solutions. Okay, Hive have capabilities to create databases. Hive have capabilities to load data. Hive have capabilities to process the data in the form of SQL. You can only write SQL queries in Hive, so you have to apply business logic around your SQL using some programming language like Python, Perl, etc. Okay, but Hive is primarily a database in Hadoop. And then you at times you have to get data from relational databases, and Sqoop is tool which can connect to the relational database, uses MapReduce to connect to the relational databases and get data to Hadoop. Okay, it is only used for the data ingestion. You cannot apply complex transformations when it comes to Sqoop. You can only use Sqoop to perform the data ingestion. And you can do some basic operations such as filtering, etc., but not very complex transformations such as aggregations. So Sqoop is primarily a data ingestion tool, not the data transformation tool. It's a data ingestion tool. It can connect to the source database and get data into your HDFS. That's it. It cannot replace your ETL tools such as Informatica or Talent by performing full-blown ETL. It's just a data ingestion tool. Whereas Hive have a lot more capabilities for the transformations. So Hive can be used to perform certain transformations, but again, Hive only provide SQL type of interface. You have to use some programming language or some other tool such as Informatica Big Data Connector or Talent Big Data Edition, which generates these Hive queries depending upon the transformations you want to perform. So Hive can be used for transformations, but Sqoop is primarily for data ingestion. Sqoop cannot replace any ETL tool. But the combination of Sqoop, Hive, along with some other programming language can actually replace traditional ETL tools to perform ETL within big data ecosystem. Oozie is a workflow tool. For example, if we go back to this diagram, okay. So traditionally what we'll do, we will get data from multiple sources. Let's say you want to generate a report, okay. For that report, we want data from multiple sources. And each source will have different SLAs. So until we get data from multiple sources, we should not perform downstream operations such as joins. So if I have to join mainframes data with OLTP data to perform certain to develop certain report, I have to wait until I get data from both OLTP and mainframes. Both cannot come in at the same time. They might come at different point in time. So we have to use some tool or a framework which can wait until data sets from both the sources came. And once both the data sets from both the sources came, we have to apply the join logic, whatever tool you want to use, and then perform the transformation, and you have to port the data back to reporting layer. So there are multiple steps involved, starting from collecting the data from source, apply the transformations, and port the data to reporting layer. And this has to be developed as a workflow. Okay, without workflows, you means you either you have to use a tool to implement that workflow, or you have to develop a tool so that data comes in a controlled manner from source to the destination. Source can be these multiple sources, and destination is the reporting layer. So that's where the workflows comes into picture. So if you want to use a tool for developing workflows, you can use Oozie here. Okay, in Hadoop ecosystem, you can use Oozie. Okay, and the reason why we need a third tool to do that is, for example, if you want to get the data from relational databases, you have to use Sqoop. If you want to get data from some file servers, either you have to have a custom solution, or you have to have some solution based out of Hive. So these two are two different technologies. And if I have to build a workflow using these two technologies, there need to be a third technology which can understand these two. Oozie is one such kind of technology out of the box with Hadoop. You can invoke Sqoop commands, you can invoke Hive scripts, or even shell scripts, or any other big data ecosystem action as part of the workflow. So Oozie you can use as a wrapper to control the execution of your application flow. So as part of Oozie, you can tell, wait until I get data from relational database using Sqoop, and also from mainframes using the custom solution. And then if both are done successfully, then perform the join between the two and other transformations using Hive. If that is done successfully, then again use Sqoop export to export the data back to the reporting database. That's how we can actually define the Oozie workflows. It is not as straightforward as it tells, but you have to first visualize the way I explained, and then you have to design an XML template for the Oozie workflow, and then you have to submit that using the scheduler. Oozie have the workflow as well as scheduler. Workflow to execute moving parts of an application using different technologies, and the scheduler to run at a particular time on day-to-day basis. And then there are other tools, Mahout, Pig, etc., which are not that relevant when it comes to data warehousing or analytics. Pig and Mahout are used in very special cases compared to Hive, Sqoop, etc. So I will not get into too many details with respect to Pig and Mahout here, but they are also MapReduce based tools, and Oozie supports them also. And then there are non-MapReduce based tools. What is the relevance of these non-MapReduce based tools? So MapReduce is primarily for processing the data. It is not for reporting the data. So that's where, if we go back to the picture, the previous one, I told you that I will discuss about this reporting database a little bit later, right? So the reason is, if you implement your EDW or analytics platform using technologies that are driven by MapReduce, you will not be able to use any reporting tool to connect to this cluster and start perform reporting over there. We have to copy data back to the reporting layer, or you have to have a another type of technology where you actually 1 minute. 1 minute, okay? I just want to confirm that the screen is still being shared. Okay, it is still being shared. So I'm going back again to the presentation. Okay, so as we cannot use the reporting tools directly based on MapReduce, either we have to port to a reporting database and connect our visualization tools to reporting database, or we have to use some other technologies. So that's where these non-MapReduce based tools play the role. So you can use HBase, Impala, Spark, etc., or even Presto, not Presto, but Impala, HBase, Spark, etc., which is better than MapReduce based tools for reporting to directly connect to the Hadoop or big data cluster and start reporting from big data systems. instead of porting data back to again the relational database, we can use these tools connected to the big data cluster, and you can start doing interactive reporting, online operations, etc. So that's where these non-MapReduce based tools comes into picture. Okay, so this is how it will look like if I want to implement data analytics application. Sqoop is primarily for extract and load from relational databases, only from relational databases. It does not work from others. Mainframes, they have little bit of capabilities which I have not explored, so I don't know whether it will work or not. Hive can be used for transformations and loading. So if you want to get transform the data in big data using MapReduce based tools, first you have to use Sqoop to load the data, and then use Hive to transform the data, and then Oozie for workflows. And you have to perform custom MapReduce also sometimes, because not all capabilities, not all requirements can be implemented using tools like Hive and Sqoop. You have to have custom MapReduce also, for which you need to learn Java. And then Impala you can use for interactive or ad hoc reporting, HBase for real-time data integration or reporting. Okay, so now comes the disadvantages of MapReduce based solutions. So MapReduce based solutions are designed for batch, not meant for interactive and ad hoc reporting. Even as part of the batch, if it is a large batch, it works very well. But if it is smaller batches, MapReduce based tools does not work. For example, in some use cases, you want to perform analytics on very small batches. Every 5 minutes, you collect the data, run some analytics on top of it, and port the processed data into a reporting layer or into NoSQL database, from which you visualize through your applications. For those smaller batches, if you start using MapReduce, the overhead is too much, and your cluster will not be effective. So it's not only challenge for interactive and ad hoc reporting, but also for streaming batch analytics. MapReduce based solutions does not work. This is typically IO bound, and processing of micro batches can be an issue. I have explained already that. IO bound means MapReduce uses a lot of IO between mapper phase and reducer phase, and also when you run complex Hive query, a complex Hive query will be executed as multiple MapReduce jobs. And there is a lot of IO that happens between these multiple MapReduce jobs for that Hive query. So it's IO bound. IO is significant here, and hence it bring down the pace at which the data can be processed significantly. And third one is, there are too many tools or technologies. So you have to use MapReduce, means you need to learn Java, you have to have Hive, you have to have Pig, you have to know Sqoop, you have to know Flume, etc. to build the applications. And also, if you want to do streaming analytics, you need to know Storm. There are many other things which you need to learn and implement these things. Okay, and because there are too many technologies which needs to be explored to build the application, your development timelines can be significantly higher. So that's where the big data teams struggle to talk to businesses when they come back with the question why it takes too much time, because in the current legacy system which is being implemented using Teradata or some other technology, if I have to develop a report, it just takes a couple of weeks or 3 weeks for end-to-end implementation. And if you go back and say that it will take 3 months for the same thing, it will not go very well with the business. So it impacts the big data capabilities of the organization significantly. Okay, and it is not suitable for enterprise hardware where storage is typically network mounted. So here, when we say enterprise hardware, you will have very high-end servers, and MapReduce is primarily designed for commodity hardware, where you have servers with 16 GB, 32 GB RAM, and 8 cores or 12 cores, and use those things to process enormous amounts of data, petabytes of data. If you want to process petabytes of the data, MapReduce will work very well. Even terabytes of data, MapReduce will work very well. But the challenges are when it comes to the micro batches or streaming analytics, and also the interactive or ad hoc reporting. MapReduce based solutions are not suitable. Okay, and the last point is very important because most of the enterprises have spent a lot of money in enterprise class hardware, where they have very powerful servers like 128 GB, 256 GB, 512 GB RAM, uh, terabytes of storage, but the storage is network mounted. So if you start using MapReduce based solutions on those hardware, it will not work, because if it is network mounted, the IO will become network IO, and network IO has to be done with through a cable or fiber optics, and as the amount of data that has to be processed grows, the issues can be significant. So that's why MapReduce based solutions are not suitable for enterprise hardware where storage is typically network mounted. Now comes Apache Spark. Spark can work with any file system, including HDFS. So Spark is not core Hadoop technology. It is big data technology, but it is well integrated with Hadoop. Okay, it can work with any file system, including HDFS. Processing is done in memory, hence IO is minimized. IO is not eliminated. You still have to do IO, but the amount of IO that needs to be done is significantly lower. Okay, especially in the intermediate stages, the IO will not be done. Very minimal IO will be done. It is suitable for ad hoc or interactive reporting or querying. Okay, streaming jobs can be done much faster than MapReduce. So if you want to perform any streaming jobs or streaming analytics, it can be done much faster than MapReduce. So either you can use Storm or you can use Spark itself to perform the streaming analytics. Applications can be developed using Scala, Python, or Java. So you need to learn either Scala or Python or Java as a programming language to build the applications. Even when it comes to MapReduce based tools, you have to learn many things. You have to learn Hive, Pig, Sqoop, and on top of that, you have to be well versed with the programming language also, not just the tools, but also the programming language or scripting to build your final self-contained application. Whereas here, you have to primarily focus on Scala or Python or Java as a programming language, and then Spark provides APIs which can talk with RDBMS using JDBC. So you don't need to use Sqoop to get data. You can use Spark JDBC connector to connect to the database and get the data. Stream data using Spark streaming. So you don't need to introduce Storm to perform streaming analytics. You just use Spark streaming to do so. The source of the data for streaming can be pulled using technologies like Flume or Kafka, and then you can perform the analytics even before loading the data into HDFS by using Spark streaming. Leverage data frames and SQL embedded in programming language. So with the previous design, if you have a Hive query, and once you get the data, once you start you wrote a Hive query, not everything can be done in Hive. You have to sometimes you have to extend whatever is done in Hive. Probably you might join the data in Hive, and if you want to do further processing on the dataset when you are trying to use Hadoop ecosystem, you have to use some other technology, either Python or Java as a programming language, and do the additional processing. And that processing is not need not be in line with the MapReduce or capabilities of MapReduce or big data. In that case, it is very challenging to extend anything on top of that data. So using Hive, you cannot build a end-to-end self-contained application. You have to use a programming language as a wrapper on top of it, and you might have to implement certain logic to build a self-contained application. Whereas with Spark, the beauty is you can embed SQL. Like if you are from application development background, you will have SQL embedded in .NET or Java, and you will perform whatever additional processing that needs to be done using your programming language. Similarly is the case with Spark. Spark provides APIs to connect to Hive, to read the data and process the data in the form of HiveQL or SQL, Spark SQL, and then you can actually get the data into RDD, which is Spark proprietary way of dealing the data in memory, and then you can start performing additional transformations on top of that. Okay, so you can leverage data frames and SQL embedded in programming language, and the programming language can be Scala or Python or Java. You don't need to mix and match those things. As processing is done in memory, Spark works well with enterprise hardware with network file system, because now as the data is in memory, as the processing is in memory, only the initial IO and final IO has to be done. Other than that, everything happens in memory, and the network usage will be minimized. Hence, you can start using the enterprise hardware where you have 128 gigabytes, 256 gigabytes, 512 gigabytes of RAM, and it uses the data locality and all those features to minimize the network usage as much as possible. And it works very well with enterprise hardware with network file system, unlike the MapReduce based solutions. So these are the benefits of Spark. Okay, and then if you want to build the same application with Spark, you don't even need to have the reporting databases, lightweight reporting database here. You can do almost everything. So Spark can be deployed on top of existing big data cluster with Hadoop. Okay, so you can use all those things, only the technology stack will change. So instead of using so many tools like Oozie, Hive, Pig, Sqoop, etc., you can use one Spark-based application or few modules to build a self-contained application. So you will have too few moving parts as part of the application development using Spark. So eventually, if people get familiar with Spark, the development timelines can be significantly lower. That being said, why Spark is getting a lot more popular? Because of all the advantages it brings onto the table. It works well with the enterprise hardware. Your application timelines can be significantly lower. You have to deal with a lot fewer technologies, etc. So that's why Spark is getting a lot more popular. And Cloudera and Hortonworks, Mapr, these three are the top Hadoop vendors, and everyone have acknowledged that, and they are pushing Spark in the big data ecosystem quite extensively. So Spark you should be familiar with if you want to sustain your career in big data. Okay. Now comes what is the future of Hive, Pig, Sqoop, Oozie, etc. Hive will be there because Hive is nothing but SQL. It has databases where you can create the tables, create database, etc. It has data load and import commands to load data into Hive, which we use as part of our applications. That can be taken care using Spark also, but Hive also can be used. But the main advantage of Hive is the databases. The architecture of Hive uses something called Hive Metastore, which contains the metadata for your data. And then when you actually run SQL queries, it uses that metadata to compile and execute. But Hive SQL is just SQL. If you know SQL, you will be able to learn Hive SQL very quickly, or HiveQL very quickly. So if you learn HiveQL, the same thing can be applied in Spark. Okay, so Hive will be there, SQL will be there, so Hive will be there. If you learn Hive, the knowledge will be used one way or the other when you start deploying your applications using Spark. Pig, I think Pig will be faded away very soon. Pig will become completely irrelevant. So Pig is a data flow language. So it's kind of a functional language. It's not a complete programming language. It's an alternative. It is developed as an alternative for Hive. People who are averse towards SQL and who want to use scripting type of language, they came up with Pig. But Spark is similar to Pig when it comes to programming constructs. Even Python is, sorry, not Spark. Scala and Python are the programming languages which are similar to pig when it comes to constructs, programming constructs, but they are a lot more powerful than pig. So as per my assumption, pig will be faded away very soon. Okay, and then Sqoop. Sqoop probably will be there, but the usage will be much lesser, only for the initial loads. If you want to get a lot of data from source database into Hadoop as part of the initial load effort, people might still consider Sqoop, but the day-to-day delta loads and all those things, Sqoop will become less relevant. It will not be completely irrelevant. There might be still room for Sqoop, but it will definitely become less relevant. And then Oozie. So the reason Oozie is developed is because to provide workflow, okay, because we have too many moving parts if you want to develop using conventional technologies. Second one is it has scheduler capabilities. And third one is, if you are familiar with Hadoop 1 and the difference between Hadoop 1 and Hadoop 2, in Hadoop 1, the master is job tracker, and it takes care of both resource management and job management. And when it comes to developing the application, Oozie addresses an issue which is called as contention on the client or gateway node. So you have the gateway node also in the Hadoop cluster. So if you start submitting too many jobs on the gateway node also have to spend some resources to keep track of the job. Okay, so Oozie addresses that issue also, because Oozie submit MapReduce jobs on when you execute the Oozie workflow. So if the workflow contains 5 different jobs that needs to be run, it will run those 5 different jobs from 5 different nodes in the cluster, because Oozie itself runs in the form of MapReduce. Okay, so it will actually reduce some of the overhead on the client also, the gateway node or client node. Okay, so it is used for workflows, it is used for scheduling, it is also used to reduce the contention on the client or gateway node. So these 3 are the main uses of Oozie. With Yarn, when it comes to Hadoop, you use Yarn, the MapReduce jobs will be submitted and it will be submitted by the client, but the life cycle of the MapReduce jobs are controlled by application master, and that application master might run on any node in the cluster. Okay, so already the contention on the client and also the resource manager is addressed as part of the Yarn architecture itself. So the third advantage of Oozie is not that relevant anymore. The contention on the client or the contention on the job tracker is already addressed as part of Yarn. Yarn takes care of a lot more other issues also. So the third advantage of using Oozie, of using the cluster to submit the MapReduce jobs rather than one client or gateway node, is already taken care. Second one is workflow. Okay, when it comes to workflow, when it comes to legacy tech, means the pre-Spark era, you have too many moving parts. As you have too many moving parts, Oozie is highly relevant, because Oozie can work as a wrapper for a Hive code, Sqoop command, pig script, custom MapReduce job, and it executes the workflow in a particular order. So as there are too many moving parts, Oozie is a very viable solution at that time. But now with Spark, you have fewer moving parts. Still there will be moving parts, but it will be fewer, because let's say if I want to get data from a source database, process the data, and store it into something else. If you have to use technologies, if you want to build that application pre-Spark, you have to use Sqoop to get the data, and then you have to process data using Hive, and then you have to load the data into HBase or whatever target system. So there are 3 different technologies implemented, and all the 3 have become moving parts, and they have to be controlled by someone. Oozie can take that role. Whereas with Spark, you can use Spark JDBC to connect to the source database and get the data, and use Spark, the programming language of your choice, to process the data. So as part of your programming language construct itself, you will be using the JDBC connector and get the data. And then you will be processing with the same programming language, and you will be loading the data with the same programming language. You don't need to use 3 different technologies. You use one programming language to do that. So there is no moving. There is only one part in that. There are no 3 different moving parts for that application. So even in the complex application, compared to pre-Spark, there are a lot fewer moving parts. Hence, for workflow purpose also, Oozie is getting less relevant. And schedulers, even before Spark also, scheduling is done by enterprise scheduler tools in most of the organizations, like AppWorks, Control-M, etc. Oozie scheduler is least used. Very few companies have used. So scheduling is already not very popular when it comes to Oozie. So that being said, for still you need to have some tool which can control the workflows. Even though there are lesser moving parts, still there are moving parts, and there has to be some technology which can control those moving parts. That's where open source technologies such as Airflow from Airbnb and Azkaban from LinkedIn can be used. So you don't need to use Oozie for that. Use simpler workflow tools such as Azkaban or Airflow. They're relatively much simpler than Oozie, and explore those technologies. And also there might be other technologies also. The landscape might be very big. Each company might have come up with their own technology, and they might have open sourced it. You have to explore those things, and you have to start using those things rather than focusing on Oozie. So that being said, Hive will stay. Hive is still relevant because the skills you learn are nothing but Hive SQL. That is the major part of Hive. That will be used as part of the Spark also. Means you should be able to write good SQL queries. So Hive will be there. Pig will completely fade out. Sqoop will become a little bit less relevant. Oozie, as per my knowledge, it will also completely fade out in next 2-3 years. So that's how the things will evolve because of the success of the Spark. And now resources at itversity before we get into the Q&A. So there are several playlists in Spark. It is not very well organized, unfortunately. You can go to here and search for Spark, and there is a Cloudera Certified Associate Spark and Hadoop developer, where we have almost 40-45 videos on core APIs of Spark. Okay, Spark have multiple modules. Most of our content is based on core APIs, but eventually we will come up with others also, like data frames, Spark streaming, etc. Okay, and there is a playlist only for Apache Spark. You can go through that. Okay, and then there is Getting Started Spark, which is 11 or 12 videos to understand how to set up the environment, how to set up programming language environments such as Scala, and then start developing Scala-based Spark applications. Just to get started with Spark and Scala, we have one video. It is not highlighted here, but we have, yeah, this, not this one. Somewhere it is there. So this video, Apache Spark introduction, is part of that one only. Okay. So not sure which playlist it is part of, but yeah, we have. Okay, so that is about the resources. When it comes to the website, it is just launched, and we have only one course, which is CCS Spark and Hadoop Developer, and it has the core APIs using both Python as well as Scala. So you can use these resources from here, or we will be uploading a lot more courses very soon, which includes Spark. So the screen share is again disconnected, so I'm sharing again. Okay, so that is about the agenda, and now I will take a few questions. We have 6 more, I think 10 more minutes time, so we will see what all questions we can answer as part of this. So the first one is from Utkarsh. So if you guys want to ask any questions, go to the events link. So it will look like this. Okay, I have already copied on my YouTube video also, the respective YouTube video comment section also. If you are watching through YouTube, in the comment section I have already placed the events link. Go to that and start asking the questions. Okay, it will look like this: plus.google.com events, etc. If you ask questions, then I will be able to see directly on the event page itself, and I will be able to answer. And also, if you are watching through Facebook or LinkedIn, etc., there also I have given this link. So you have to go to this link to ask the questions. Then only I will be able to see them. So the first question is, 1 minute. The first question is, I am a student under OPT. I have taken subscription for CloudX Lab for 3 months. Is it enough for certification purpose? Do I still need to install Hortonworks, Sandbox, or Cloudera VM for practice, or CloudX Lab is enough? So if you don't have 16 GB laptop, if you cannot invest money on that, yeah, you have to use some resource like CloudX Lab to keep on learning. Okay. So it's if you have 16 GB laptop, I will highly recommend you to have a Hortonworks Sandbox or Cloudera VM. That will give a lot more flexibility, will have root permissions and all those things. So you will be able to explore quite a bit without being limited with the restricted access to the cluster. That being said, it depends upon your background. Most likely 3 months is enough if you practice enough. Most, as you are on OPT, if you are not working on a project, 3 months would be good enough for the preparation. If you stay focused and prepare for the certification and give the certification. I have the history of mainframes people, freshers with OPT who completed with 2 months or 3 months of effort. Okay, then the next question is from Wajid Ahmad. I want to start career as a Hadoop developer. I graduated recently and I have been following your lectures and videos on Hadoop on YouTube. Do I need to know thoroughly Spark to break into, and what is the scope for a fresher? So having the Spark knowledge will definitely help you to get some traction to your profile, because there are hardly any developers who are well versed with Spark, who are and experienced. So if you can build the Spark skill also, it will definitely help boosting your job search. Okay. And up to what extent you need to know, no need to be thorough, focus on the core APIs and learn one of the modules, either data frames or Spark streaming, probably Spark streaming or both, data frames and Spark streaming. No need to focus much on MLlib or graphics. They are not used that extensively. Focus your energies on other popular technologies where you can get your job quickly. So the next question is, do we have to choose language in CCH Spark exam, Scala or Python? Do we need to learn both languages? Again, it depends upon the certification you want to give. If you want to give CCS Spark and Hadoop developer, you have to know both Scala and Python, but you don't need to be a master of it. They will give the code snippets and they will give the case. You have to just use the Spark-based APIs using Scala or Python programming language, and you just have to replace that. And Spark-based APIs are strikingly similar between Scala and Python. Hence, if you learn extensively on one and do some practice on the other, it is good enough if it is CCS Spark and Hadoop developer. If it is HDP CD Spark, which is Hortonworks certification, you just have to focus on one programming language. You can answer all the questions in the programming language of your choice between Scala and Python. If it is, I think Databricks conducts test only on Scala. I'm not 100% sure. I'm not 100% sure about Mapr also. But Hortonworks, you just have to know one programming language and you have to focus only on Spark. When it comes to CCES exam, you have to know both Scala and Python. Okay, you are asking this with respect to CCS, so you have to know both Scala and Python. but you don't need to be a master of it. You will not be developing end-to-end solution as part of the certification exam. So the next question from Ravi, I am interested in admin course. Do you have access? Do you have any courses for admin? Yes, if you go to my channel, there are a lot. You can go to Hadoop administration section on my channel's homepage. So there is Hortonworks and there is Cloudera. Even within Hortonworks and Cloudera, this playlist focuses on AWS. So if you don't have 16 GB laptop and if you want to build your cluster, unless you build the cluster, you will not be able to learn Hadoop administration. You will be able to learn only when you build the cluster. Either you have to use your 16 GB laptop or you have to spend money on cloud providers such as AWS. So this is for Hortonworks administration, Hadoop administration using Hortonworks on AWS. This is on the same thing on virtual machines. And this one is Cloudera on AWS, and this one is Cloudera on VMs. So depending upon where you want to set up the cluster and what distribution you want to explore, you can choose one of them. Okay, and Hadoop is an open source. Cloudera and Hortonworks are just wrappers around it. Once you learn using one distribution, it is very easy to learn on other distributions. Even if you follow my videos with the other distribution, you will gain some knowledge. But I have not uploaded any content to my website yet, which I will be doing soon in next 2 to 3 months. Okay, so let me. So the continuation from Ravi is, can I practice Hadoop administration on CloudX Lab as I do not have 16 GB laptop? No, you cannot, because you need to have a 6-node cluster, or you need to build multi-node cluster, and CloudX Lab is only for the developer part of it. You cannot actually practice the administration things on CloudX Lab. You have to either upgrade your laptop or buy a new laptop or spend money on AWS. If you go through my AWS videos, you will understand the pricing of AWS to explore these things. And you have to first understand how much money it will take and how many hours of time you want to spend. Then only you can you can actually learn something. Then only you will save money. Otherwise, you will waste a lot of money. So first, go through my videos before provisioning EC2 instance. Calculate first plan how many hours you want to spend within a month or 2, and then estimate the cost and review the cost with me before starting on AWS. Okay, so the next question is from again, there is a follow-up from Ravi itself. What if I want help from you? I'll be helping you on smaller issues, but if you want me to troubleshoot your issues and all those things, I have a batch which is going on 2 times a week. You can be part of it, but there's a cost associated with it. It is $150 unless you are a student. If you are a student, I can take care of it for free. But if you are not a student, you have to pay $150 for those live sessions where I will be troubleshooting the issues, and I will be make sure that you my presence will accelerate your learning. But you can send an email at any point in time, and I will try to respond as quickly as possible. I will recommend you to actually go through the playlist first, and then based on your experience, make the decision. So the next one is from Sandeep. There are multiple questions. Let me take Sandeep's questions first. Okay. So with respect to class, I will send me an email to training@itversity.com. Again, Ravi have the follow-up question. Let me answer that. So yeah, send me an email to training@itversity.com, and then I will. The timings are Wednesday and Friday, US time in the evenings, Eastern time 8:30 p.m. Wednesday and Friday. Okay. I might change it a little bit. I might make it Monday and Wednesday rather than Wednesday and Friday, so that you don't you don't ruin your long weekends and all those things. But Wednesday will be there. Other day could be Friday or Monday. It depends upon how it evolves, and also the preferences of the other students also. If you are based out of India, it is morning 6 to 7:30. Okay, so send me an email at training@itversity.com, and then we will take it from there. That being said, now I will go to Sandeep's questions. So the first one is why, I don't know which one is the first question. Let me take this. While we want to do some performance tuning on Spark with large terabytes of data, how can we do performance tuning? I think we can increase the memory of the Spark executors. Is there any other solution that you can recommend to improve the performance? Performance tuning by increasing the memory should be the last resort. Once you sort out all the other options, then only you should focus on that. Performance tuning takes a long time. It takes a lot of effort. You need to have in-depth knowledge, not only on Spark, but also data modeling and many other things. Then only you can come up with a good solution. One of the straightforward solution is to increase the executor's memory, and people start using that, but that is a poisonous pill. If you use it incorrectly, it can kill. Okay, so make sure you sort out all other options before increasing the memory of the Spark executors. And also he has another question, Sandeep. Can Spark streaming works with complex event processing like Storm? I think all are used for real-time streaming. What is the main difference between them, and which framework is better when we use it in production environment? So Storm and Spark are competitors in a way, because they're trying to address the same problem, which is streaming analytics. So either you have to use Storm or you have to use Spark streaming. Okay, I'm not sure which one is better, because I don't know. I don't have much knowledge about Storm. But to stream the data, first you need to have either Flume or Kafka as a gateway where you can get the data, and then okay, and then you have to use either Storm or Spark. Okay, that's a valid point. So this is primarily for comparing the Spark and someone. I don't know. Someone is commenting, but I'm not seeing those comments here. So I think you are asking. You are pasting the comments. I don't know that gentleman's name. You are actually commenting on the event. So let me go to the event page. I'm not seeing in the Q&A session. It will be better if you actually post your comments as part of the Q&A. I don't know. I'm seeing notifications, but I'm not seeing the comments from one gentleman. Okay. Anyway, so do you have any Spark only course starting in coming weeks? I have knowledge in MapReduce, Sqoop, Hive, and basic programming in Scala by Sujit. No, I don't have any Spark only course in coming days. I'm primarily focusing on big data engineer. So, but Spark will be a major module in that, and we are already in touch about that. We will discuss further on this offline. And then Midun have asked the question: do we get calls for big data engineer positions if we don't have experience? So whether you get calls or not, it depends upon other factors. Okay, you have to prove your skill if you want to get as a fresher. Just clearing CCA 175 and just going through the course will not take you to there. Okay, so you need to understand other factors also, and based on that you should focus on. As part of the big data engineer course, there will be multiple things which you need to learn. And if you learn those multiple things, you will end up getting one or the other role. Okay. Tausif, he's saying that I got dropped in between. How long is the course and what is the cost? This is not about the course. This is primarily to compare the Hadoop MapReduce and Spark and how it works. So if you want to know about the coming big data engineer course, already there is a hangout conducted, and you can go to my channel and search for hangouts. Okay, I'll go to the playlists. You can go to this hangouts. So all the hangouts will be here. Okay, so there should be some big data engineer one also here. I think I did not add it to this, but I will add it to this. Yeah, here, big data engineer immersion, September 2016. You have to watch this video. Okay, so I don't know where. Yeah. Now I can see Sarvanan's comments. So he's asking, is Spark using MapReduce behind the scene like Hive? No, that is not the completely correct statement. It will be better, Sarvanan, if you ask the questions as part of the event Q&A page. I think you are just posting the comments. That's why your comments are not coming up as part of the Q&A. Anyway, I will answer your questions. It is not like, let me refresh this. You have few more things. I got notifications from you. Okay, only 2. So it's not completely true. The query Spark. So Spark has APIs, and Hive have different things. Hive and Spark should not be compared at all. Spark have APIs, and Spark can work with multiple programming languages. And they provide APIs with Scala. For Scala, they provide APIs for Python. They provide APIs for Java. Okay, whereas Hive is just SQL. It does not have anything else. Spark can actually, as part of Spark applications, Spark-based applications using Scala or Python, you can embed the Hive queries as part of the your applications, and you can execute your, you can build the applications around it. So the comparison itself is not correct. Okay, and yeah, you said I joined just like that without knowing your schedule. Thank you for your effort. First, may I know where can I get your schedule for live lecture? I will. So as you have joined late, we will discuss all these things in detail later. I will pass on your question for now. I don't know what your prior experience is to answer this question. Look at my Hangout. I will be. It will be available in this Hangouts playlist very soon, and it will be. You will be able to watch within 10-15 minutes after this. Look at this, and you can start commenting as part of the YouTube video, and I will try to respond. Also, we can touch base, and we can see what can where you are and what your actual questions are, and I will be able to answer your questions. Okay, that being said, it's the last question. I will not be taking any more questions. It's again from Sandeep. Thank you so much. I am OPT student. I have learned Spark and Hadoop. I installed HDP on my laptop. Planning to take the certification. Can I join the Spark course? Yes, you can join Big Data Engineer Immersion course. It is not free for OPT. You have to talk with your employer. If you want to learn for free, there will be self-paced online course. I will be conducting regular hangouts, and you can be part of it, and I'll be able to respond. But if you want to be part of my live course, then you have to pay the fee. And I'm not 100% sure whether I will be conducting the live course or not. It all depends upon the response. I typically deal with larger batches. So I need at least 20 to 25 people in the batch. Unless I get those many people, I will not be conducting that. That being said, definitely the course will go, the self-paced model will go. It will be free for MS students, OPT students. And they can the course will be available on LMS platform. They can start going through the course, and I will be conducting the regular hangouts, and I will be clarifying your doubts and issues. And also we have LinkedIn groups. Be part of those LinkedIn groups, and you will be able to post your questions over there also. And slowly it will evolve in such a way that people will start responding to your questions without me becoming the bottleneck. Okay, so that being said, I hope you have enjoyed the session. We will be conducting many hangouts like this over time. I'm also motivating other people who have prior experience in big data to come on board and talk on these hangouts. So please follow us on Google Plus and stay tuned for our future hangouts. You will see at least one hangout every week on one or the other topic. So follow-up question from Sandeep: will you cover all modules on Spark? I will not be covering MLlib and graphics. I will be covering core Spark. I will be covering data frames. I will be covering Spark streaming. Okay, those are more important than MLlib and graphics. If you start getting into MLlib and graphics, you will waste a lot of time. It's better for you to focus on other technologies which are relevant for the big data engineer role. Okay, like if you have time, focus on Azkaban to use it as a workflow tool, or focus on Amazon EMR, Elastic MapReduce on Amazon. So the more skills you add, the more the broader will be so you will be eligible for broader number of jobs. If you just focus on Spark, and if you're just trying to learn Spark end to end, you will end up spending a lot of time, and then you will be narrowed down. Okay, so try to broaden your criteria where you will be suitable for broader number of jobs rather than narrower number of jobs, because to begin with, getting the job should be our top priority. That being said, thank you very much, and stay tuned for further hangouts. And please follow on Google Plus or Facebook or LinkedIn so that you can get updates from the hangout. And more importantly, if you are part of the hangout, it will be easier for me to communicate with you guys. Even if I forget to paste in Facebook or LinkedIn, still you will be getting the updates. And also, if you want to get an email as an update, send a request to itversity@googlegroups.com. We have Google Groups. You can be part of that, and I will be sending notifications as part of the email also. So itversity@googlegroups.com is my Google Group name or email ID. So the question from Sandeep, this is the last question. Even if you have some follow-up questions, we have to take it offline. Can we create Amazon EC2 instances for Spark worker nodes? I am thinking in real world they will use AWS. That is correct. In some of the cases, they use AWS for doing so. Okay. Okay, then have a nice one. Thank you. Bye.